So good morning. So now we discuss classification of magnetic substances. So now we are going to study the various types of magnetic materials in terms of the magnetic properties of the atomic dipoles and the interactions between them. So very first discussions are based on whether the atoms carry permanent magnetic dipoles or not. So materials which lack permanent dipoles are called diamagnetic. So the atoms of the material carry permanent magnetic dipoles such as material may paramagnetic, ferromagnetic, antiferromagnetic or ferrimagnetic. So depending on the interactions between the individual dipoles, if the permanent dipoles do not interact among themselves, the materials is paramagnetic. If the interactions among permanent dipoles is strong, which that all the dipoles line up in the parallel, so the materials are ferromagnetic. So if the permanent dipoles in the line the antiparallel directions, antiferromagnetic and ferrimagnetic. So the antiferromagnetic materials, the magnitudes of a permanent dipoles aligned parallel and antiparallel are equal, and hence the magneticization vanishes. So in the case of ferrimagnetic materials, magnitudes of permanent dipoles align the antiparallel are not equal, thus exhibiting a magnetization. So materials not having permanent magnetic moment, that means diamagnetic materials having a permanent magnetic moment, paramagnetic material, ferromagnetic material, antiferromagnetic material. So that magnetism in a matter. So the magnetism matter is that the magnetic states of substance is described by the quantity called the magnetization of vector m. So the magnitude of this vector is defined as the magnetic moment. So per unit volume of the substance, so that means magnetic moment per centimeter cube. So that magnetic moment is also called a magnetic dipole moment. So is a measure of the object's tendency to align with the magnetic field. Its positive direction depends on the way the object responds to the magnetic field. So the total magnetic field induction at a point within the substance depends on the applied external field and the magnetization m of the substance. So recognizing the similarly between m and h, we can write B equal to mu naught h plus m. So also already we know that mu naught is the constant called permeability of free space, that is equal to 4 pi into 10 power minus 7 Tm by ampere. So the h is the magnetic field strength within the substance. Okay, so the quantities h and m have the same units because m is the magnetic moment per unit volume. Its SI unit is a or ampere meter square per meter cube equal to A by m. So for these substance placed extra magnetic field, we can write m is equal to susceptibility h, psi h. So already we know that psi is the susceptibility. And then substance can be classified, already we know that belongs to three categories: paramagnetic, ferromagnetic and diamagnetic. So the paramagnetic materials are those made of atoms that have permanent magnetic moments. The two most common types, so one is the paramagnetic and the diamagnetic. So diamagnetics are those made of atoms that do not have a permanent magnetic moments. The magnetic property of a substance can be determined by the examine is the electron configuration. It has the unpaired electrons. The substance is a paramagnetic, and if all the electrons are paired, and the substance is themselves diamagnetic. So first we discuss a ferromagnetic. So there are certain substances like iron, nickel, which have the high degree of magnetization in spite of their randomizing tendency of the thermal motions of atoms. These materials are called ferromagnetic, and phenomena are called as a ferromagnetism. So even though the net spin magnetic moment of these materials are of the same order of that of the paramagnetic material, still exhibit strong magnetizations. This is due to the spontaneous magnetization. This occurred due to the special form of interactions called exchange coupling between adjacent atoms, even in the absence of applied magnetic field. Coupling their magnetic moments together the right rigid parallelism. So when placed in a magnetic field strongly attracts the magnetic lines of forces. It has the characteristics temperatures called the ferromagnetic Curie temperature theta f. So the permeability depends greatly on temperature. So the paramagnetic properties are quite different. It behaves as a paramagnetic material. The spin alignment parallel. These materials consist of a number of small regions called domains, which are spontaneously magnetized. So thank you. We discuss on another two next session.